Alright, here's the example question. What we have to do here is find the molar mass of quinine. We're given the freezing point depression constant for cyclohexane. So here's what I might think. I would say the molar mass is grams per mole, and we're given the grams up here. So we just need to find out how many moles of it is in this solution, which might be hard to do in one step. But we do have a pretty simple equation that will tell us the change in freezing point based on the concentration of the solution. So yeah, we know that the more concentrated this solution is with quinine, the more its freezing point is going to change. And this Kf is the 20.8 that's given to us. And that's the constant for the solvent. So a good first step here would be to solve for the molality of the quinine. And we just divide both sides by that constant, plug in our numbers, and that is a concentration. So the actual number of moles will be proportional to the mass of solution we have. So it makes sense that we should multiply this concentration by the mass of solvent. And we can double check that that makes sense by making sure our units cancel appropriately to give us the right units of our answer. And right now, they're not canceling. So we should convert to kilograms. And this should work a little better. We end up with moles of quinine, specifically this many. And I just want to point out that molality here is moles of solute per kilogram of solvent. So I just rewrote this with the units more explicitly stated. And at this point, I've almost forgotten why we were finding this, but this is the plug-in here. So yeah, we just plug in our grams over our moles, and that gives us the molar mass. Let me throw one more example at you. I don't want to do this one all the way through, but here's what to think about. This might be a more simple application of our equation for change in boiling point or freezing point temperature. So like we saw before, you get this constant times the molality. But what we need to include, if we don't have a molecular compound, is the Van't Hoff factor. And in this case, this compound is going to break into 3 separate ions, and assuming 100% dissociation, that means 3 ions per clump. That means our I is going to be 3. So our effective concentration is going to be about 6. And let's see, how would we find this constant here? This is for the solvent. Here's the clue that tells us that water is the solvent. And one more thing, this equation tells us the change from 0 degrees Celsius. This isn't the actual freezing point temperature itself right here.